Today we are going to talk about the four methods of electron emission. There are four methods of electron emission. The first one is called thermionic emission. The second one is called field emission. The third method of electron emission is photoelectric emission. The final method is called secondary emission. So we will see them one by one. Let's talk about thermionic emission first. Here in the name itself, you can understand exactly the meaning of the title. Thermionic emission means with the help of thermal energy, electron emission is possible. Let us imagine a metallic surface. So within the metal, plenty of free electrons are available. Some of the electrons, they are very closer to the surface also. So at normal room temperature, no electron will be emitted from the surface. So what we have to do? We have to supply sufficient amount of energy that is to be supplied in the form of thermal energy. If the metal is heated to a very high temperature, what will happen? That metal, it will absorb the heat energy. After absorption of heat energy, what will happen? After getting the sufficient amount of work function, the electrons very closer to the surface, they will come out from the metal. So the electrons, they are coming out from the metal one by one. These kind of electron emission is called as, what is it? Thermionic emission, because the metal gets heated. Okay, after attaining the sufficient amount of kinetic energy, what will happen? The electron, they are liberated from the metal surface. This kind of electron emission is called thermionic emission. So here heat is supplied. Because of the heat, thermal energy, the electrons are liberated from the surface of the metal. That's why this is called as thermionic emission. The same thing that can be observed in the case of filaments, especially in the case of tungsten filaments. What will happen if sufficient amount of voltage is given across the end of the tungsten filament? Here appropriate voltage must be given. Here when the voltage is increased, the current passing through the filament will also increase. Are you clear? When V increases, the current passing through the filament will also increase. We know the formula from Joule's heating effect. H is equal to I square RT, that is the formula. Are you clear? Tungsten, it is having very high resistance and current passes through the filament also. So with the help of the high amount of current, high resistance, if the current is allowed for long time, what will happen? More amount of heat will be generated. So the heat is supplied to the metal. Okay, so the heat gets here, the filament gets heated. When filament gets heated, what will happen? No, this one becomes red hot. This particular part, that one becomes red hot. Okay, so the filament, that one gets red hot, and this part alone will get red hot. So there from the metal surface, from the tungsten filament surface, plenty of electrons will be emitted from the metal surface. So they are liberated from the metal surface. This kind of emission is called as, what is this? Thermionic emission. Even in the ordinary bulbs, electrons are emitted from the metal surface. Okay, so these kind of filaments, they are used in X-ray tube, cathode ray tubes, and also in the case of electron microscopes. In cathode ray tubes, and also in electron microscopes, X-ray tubes, these filaments are used. There the filaments gets heated by supplying the very high voltage. With the help of this, electrons are liberated. Electron emission takes place. Note down the three appliances. X-ray tube, Coolidge tube is otherwise called as X-ray tube. Are you clear? And then cathode ray tube. In the next lesson, you are going to learn about cathode ray tube. There cathode rays are emitted, electrons are emitted. Okay, so there also the same kind of filaments are used. And also in the case of electron microscopes. Okay, in the case of electron microscope, the electron is the key particle. Okay, so the electrons are emitted from the filaments. Electron microscope also, these kind of phenomena, thermionic emission is used. Don't forget, these are all the three appliances in which thermionic emission takes place. Okay, with the help of thermionic emission, electrons are liberated, electron emission takes place. Now we are going to see the second method of electron emission. The name of the method is called field emission. In the name itself, it is clearly understood that with the help of electric field, electron emission is possible. Let us imagine a metallic surface within which plenty of free electrons are available. Some of the electrons, they are very closer to the surface also. Some of the free electrons, they are very closer to the free surface. So here the metal that should be placed within the two electrodes. So here one positively charged plate is there, here one negatively charged plate is there. In between these two plates, a strong electric field must be applied. Okay. So here by increasing the number of charges, positive charges and negative charges, very strong electric field that could be applied here. So plenty of electric lines of force, they are traveling from positive end to negative end. We know very well that the electric field is acting in this direction. The direction of the electric field must be taken right from positive end to negative end. Are you clear? So here we know the one basic important formula that F is equal to electric force acting on the electron, that can be taken as F is equal to E into E. Electric field strength into the charge of the electron. So electric force is acting here, and that positively charged plate that tries to pull all the electrons out. Since the electric field is so strong, the electric force will also be very strong. Therefore, due to the strong electric field, due to the strong electric force, all the electrons, they will come out one by one, and when the electrons they are coming out, it can be taken as the field emission, electron emission. So when the electrons are liberated from the surface, the free electrons, they are available in the space and they are coming out one by one and they are moving towards the positively charged plate. So this kind of electron emission is called as field emission, that is purely taking place because of the presence of the strong electric field. So this electron emission, that is field emission, that is used in the following devices: field emission scanning electron microscope, and also in the field emission display. In those two appliances, the electrons are liberated, electrons are emitted with the help of the process called field emission. Okay, very important one. So here the electrons are liberated, emitted only with the help of the presence of the strong electric field. Already we have learnt about the two processes of electron emission. Already we have seen about thermionic emission and the field emission. Now we are going to see the third process of electron emission called photoelectric emission. So here the meaning of photo is nothing but light. Photon, light particle, is otherwise called as photon. So here we have taken a metallic surface. So within the metallic surface, plenty of free electrons are there. Some of the electrons, they are very closer to the surface also. So here this metal must be a photosensitive metal. Are you clear? The best example for photosensitive metals are cesium, sodium, potassium, calcium. These kind of metals, they are all called as photosensitive metals. So whenever the electromagnetic wave radiations of appropriate frequency, when they are made to incident on the metallic surface, what will happen? No, these radiation, they are having energy. Okay, these electromagnetic wave radiation, they possess energy. So these energy of the electromagnetic wave radiation, they are transferred to the electron. So if sufficient amount of energy is given to the electron with the help of the electromagnetic wave radiation, these electrons, they are able to overcome from the metal surface. So the electrons which are emitted from the surface of the metal, they are called photoelectrons. Okay, so the liberation of electron that takes place from the metal surface with the help of the electromagnetic wave radiation, especially with the help of light. Since the emission, electron emission, that takes place with the help of light or with the help of electromagnetic radiation, this phenomena is called as photoelectric emission. Okay, mainly this photoelectric emission phenomena, that one takes place in the case of photoelectric cells. So here the light energy that is transferred to the electron. Okay, if sufficient amount of energy is given, electrons are liberated from the metal surface. These electrons, the liberation of electron, no, the emission of electron, the emitted electron, they are called as photoelectrons. Okay. Now we are going to learn the last method of electron emission, that is called secondary emission. Here you have to assume a metallic body. Within the metallic body, plenty of free electrons are available. The fast moving electron from some other source, they are made to incident on the metal surface. Usually the fast moving electron, they will have tremendous amount of kinetic energy. Their speed is also very high. Their kinetic energy is also very high. They have sufficient amount of energy and they are able to transfer their energy to the free electron. After gaining some amount of energy, sufficient amount of energy, these electrons, they will become free and they are ejected out from the metal surface. So these are all the fast moving electrons. They are made to incident on the electrons of the metal. These electrons, after gaining the energy, clear, after gaining the energy means after getting the energy of work function, these electrons, they are coming out from the metal surface. Are you clear? These electrons are called secondary electrons. These electrons are called secondary electron. Actually, these are all the fast moving electron. These are all the electron were previously at rest. These fast moving electron, clear, they are capable of removing this electron because they have sufficient energy. They have tremendous amount of energy. So the energy is transferred here. So that's why these electrons should be called as secondary electron. These electrons are called as secondary electrons. Okay, that's why this emission is called as secondary emission. Secondary emission. This secondary emission that mainly takes place in few appliances. In the following appliances in which secondary emission takes place: image intensifiers, photomultiplier tubes. In those devices, secondary emission